All right, welcome to the Explainer. Today, we're going to do something really practical. We're taking a Cisco ASA firewall, fresh out of the box, and I'm going to walk you through the essential steps to turn it into the secure heart of your network. Let's get started. So, here's the game plan. We'll kick things off by getting a feel for the ASA's command line. It's a little different. Then, we'll build out the basics, get organized with something called object groups, lay down the law with ACLs, connect to the outside world using NET, and finally, we'll lock the whole thing down with AAA. A lot to cover, so let's jump right in. Okay, first things first. Let's get to know the ASA's command line. Now, if you've spent any time on a Cisco iOS router, you're going to feel mostly at home here. But, and this is a big but, the ASA has its own personality, a few little quirks that can trip you up if you're not ready for them. And here's a perfect example of what I'm talking about. On an iOS router, right, you've probably typed show IP interface brief a million times. Well, on the ASA, they just flicked it. It's show interface IP brief. Same thing for saving your config. That muscle memory for copy, run, start, you gotta retrain it. Here, it's just write memory. It's these little things, these small differences that are so important to nail down from the very beginning. Okay, let's start building. This is where we lay the foundation. We're going to give our ASA its basic identity and get it plugged into the network. These are the absolute must-do first steps. So these are the non-negotiables. First, we hop into privileged mode, and believe it or not, there's no password by default, so we'll fix that. We'll give it a host name, a domain name, then something super important. We're going to lock down the passwords with a master phrase pass and turn on strong AES encryption. After that, it's all about the interfaces, giving them names, security levels, and IP addresses. And the final piece of this puzzle is setting up a default route so our firewall actually knows how to get to the internet. Now, this concept of security levels, this is maybe the single most important thing to understand about the ASA. Seriously, think of it as a trust score from 0 to 100. 100 is max trust. That's going to be your internal, inside network. 0 is zero trust. That's the Wild West of the internet, your outside interface. Everything the ASA does by default hinges on this simple number system. Okay, our foundation is solid. Now it's time to get organized. Look, nobody wants to write firewall rules for every single IP address. It's a nightmare. So we're going to use something called object groups. I love the guest list analogy. It's perfect. You're not checking IDs one by one. You're just checking if they're on the list. It makes life so much easier. So what is an object group, really? It's just a bucket, a named container. You can throw a bunch of similar things in it. For example, you could have one object group for all your web servers, another for all your database servers. You could even have one for services, like one called web_stuff that has HTTP and HTTPS in it. The beauty is, you then write one rule for the group, not 10 rules for 10 different servers. It's clean, it's simple, it's the right way to do it. And this is what it looks like in the command line. You can see we can create an object network for a single host, like one web server. Or we can create one for an entire subnet, our whole inside network. Then the magic happens. We create an object group, give it a name like servers, and just start adding those individual objects we already made. It's that simple. And trust me, when your network grows, you will thank yourself for doing this. All right, our guest lists, our object groups are ready. Now we need to hire the security guards. That's where access control lists, or ACLs, come in. These are the rules of the road. They stand at the door of each interface and check every single packet to see if it's allowed in or not. But wait, before we write a single line of an ACL, here's another one of those iOS versus ASA gotchas you have to know. On a router, you use wildcard masks in your ACLs, right? 0.0.0.255 and all that? Throw that out the window. On an ASA, you use a normal standard subnet mask, 255.255.255.0. It's a super common mistake for people coming over from the routing world, so burn this one into your brain. Okay, remember those security levels, the 0 to 100 trust score? Well, this is where they really shine. Out of the box, the ASA has a built-in rule. Traffic can always flow from a higher number to a lower number. So from your inside interface at level 100 out to the internet at level 0, no problem. But what about the other way? Traffic from the internet trying to get in? Nope. Denied by default. That's your first layer of security, and you haven't even written a rule yet. And boom, here's where all that prep work pays off. Look at how this ACL reads like a sentence. We create an access list named outside in. The rule says, permit TCP traffic from the object group trusted hosts to the object group servers for the services in the web services group. Isn't that clean? It's so much easier to understand than a list of IP addresses. Then, the last step is to just apply that access list to the outside interface, telling it to check all incoming traffic. So our security rules are in place, but there's a problem. Our internal users can't actually get to the internet yet. Why? Because they're using private IP addresses. That's where network address translation, or NAT, comes in. The ASA is going to be our translator, taking those private internal addresses and converting them to a single public address that the internet can understand. Now, the ASA does this in two main flavors. The first is dynamic PAT. Think of this as the many-to-one translation. It takes all your internal users, hundreds of them maybe, and funnels them all out through one single public IP address. This is perfect for everyday web browsing. Then you have static NAT. This is a one-to-one deal. You're creating a permanent VIP lane, mapping one public IP directly to one internal server. This is how you make your web server or mail server visible to the outside world. And you know what? Getting your users online with PAT is ridiculously easy. Seriously, it's just 2 steps. Step 1, define your inside network using one of those object groups we just talked about. Step 2, write a single NAT rule. And that rule basically just says, hey, ASA, anytime you see traffic from that inside network going out, just translate its address to whatever your public IP is. That's it. You do that, and your users can browse the web. Okay, so our firewall is doing its job. It's passing good traffic, blocking bad traffic. But we've forgotten one very important thing, securing the firewall itself. We need to control who can log in and make changes. And for that, we turn to the classic AAA framework: authentication, authorization, and accounting. So here's how we're going to lock it down with SSH. First, we need a user, so we create a local username and password right on the device. Simple enough. Next, SSH needs encryption keys to function, so we generate those. Then, as a good security practice, we'll specify exactly which internal networks are even allowed to attempt an SSH connection. And the final piece is the AAA rule itself. We're just telling the ASA, hey, for any SSH connections, I want you to check them against the local user database we just created. Done. Now only authorized admins can get in. So let's just take a step back and look at what we've done. We started with a blank slate, a default device, and now we have a fully functioning firewall. We got comfortable with unique CLI, we mastered the core concept of security levels, we learned the smart way to build rules with object groups, we set up those ACLs, we got everyone online with NAT, and we locked down the management door with AAA. That right there is a solid, secure foundation for any network. But that brings up one last really important question. Your firewall's configured, it's running, but who's watching it? Configuration is just step 1. That firewall is now a fire hose of information in the form of logs, every connection, every dropped packet. The real job of a security pro is monitoring those logs, understanding the story they're telling, and being ready to act. You see, getting the configuration right gets you into the game, but paying attention is how you win.